In this video, we're going to focus on the project by looking at a new concept from economics called the consumer surplus. So recall that we have an assumption here in our project that we have a temporary monopoly for the product that we're working with. That basically means we don't have any competition to worry about. And so, in turn, that means, in theory, that we can be what are called price makers, which just means that we get to set the price and not have to worry about competition. However, we do have to take other things into consideration, such as what is the best price that we should charge in order to maximize our profits. And we've been doing that kind of analysis. But in that situation, we can also explore this theoretical idea from economics where we look at consumers who are willing to pay more than the price that we set. So if someone is willing to pay more than the price that we set, then to that consumer or to those consumers, they can be thought of as having a surplus or a savings. They're willing to pay more than what we charge them for. And so that's why this is called the consumer surplus. And the idea behind the consumer surplus is to take the sum of all the money that consumers would save if they're willing to pay more, but only end up having to pay the lower price that we set. And we'll go into this in more detail in a moment, but that's the general idea. Now, note for a moment that there's also a concept called the producer surplus. But it's not going to make any sense to talk about that in this situation because it doesn't work in a monopoly situation. So in a monopoly situation, we can only talk about the consumer surplus. Later, we're going to remove that assumption. But right now, we're just going to focus on the consumer surplus. So let's take a look at the picture. Let's suppose that the price for this item is set at the actual price that maximizes the profits, which we've already been computing. We're going to call that price P plus. The plus just means it's the best price. Now we know that there is a corresponding quantity, Q plus, that corresponds to that price that's on the demand curve. In fact, the way that we got this point was we took the derivative of the profit function to find the quantity, Q plus, that maximizes profits, and then we plug that into the demand function to get its corresponding price. And those two values go together and create a point on the demand line, which you can see down here, which is this orange curve. So I've labeled the best quantity and best price together as a point on the demand curve. Now notice points on the demand curve to the left of that correspond to prices that are above where we actually set this item. So if you look at this dot right here, you can see that corresponds to a price of about, let's say $560. So this is all the consumers who are willing to pay $560 for this item, but we're only going to charge about $400 for it. So to those consumers, that can be considered as a savings or a surplus. And that's represented by that vertical arrow here. Now, notice that all of these points on the demand curve up to this P plus, Q plus P plus point, all of them represent another price above P plus that people are willing to pay. So for example, right here on the demand curve, you can see this corresponds to the point where the price is at $500. So there's some people, well, they're not willing to pay $560, but they are willing to pay $500 for it. Well, if they only have to pay $400 down here, then this distance represents the surplus for them. So now imagine all of these prices creating a bunch of vertical lines. And if you add up all those vertical lines, so to speak, you could line them up and add them all up and fill in all of the gaps between them. In theory, you end up with this yellow region. And that yellow region is called the consumer surplus. And for that reason, it is an area. More specifically, it's the area between the demand curve and the flat horizontal line or the function that corresponds to the optimal price. And so what we're going to do, as we've just recently seen, is we're going to find the integral so that we can find the area between these two functions. So that's the basic idea. We're going to sum up the area across all the prices that are higher than P plus, right? And therefore they're to the left of that point, Q plus and P plus. And when we do that, we get the region called the consumer surplus. It is an area. And so in terms of integrals, the consumer surplus is equal to the integral from 0 to Q plus. Right? So let's look at the limits of integration first. We start at a quantity of 0, which makes sense here. And then we go all the way over to where those two functions intersect, which of course is at the value Q plus. So that's why we have an upper limit integration of Q plus. So we're going to take the integral of the demand function minus P plus. Because as we've seen previously, to find the area between two functions, we take the integral of the function that is above, which in this case is the demand function. You can see that's above the flat line. And then we subtract the function that is below. And that's how we find the area between two curves. So we also have talked about how if you have an integral of a sum or a difference, like we do here, we can break this out into two different integrals. So I can look at this as the integral under the demand curve minus the integral under the P plus line. Or so another way of saying that is, this is the area, this integral is the area under the demand curve minus the area underneath that green dotted line. Now, visually, if we think about this first piece, the area under the demand curve corresponds to this region on the graph, which is outlined in this purple dotted line. So imagine this whole thing being shaded. The area of this region is the integral of dq from 0 to q plus. But of course, that's too much area. We don't want this lower area down here. We need to take it away to leave the yellow region remaining. So that's what happens here when we subtract off the integral of P plus. This is the area underneath this curve, this line. So it's the area underneath the green line down to the x-axis. And that's the red rectangle. So if I start with the purple rectangle, the large area, and then I remove the lower red rectangle, what remains is the yellow shaded region, and that is called the consumer surplus. So if we take a look at the class project and we were to do this integration, the consumer surplus is the integral of the demand function minus the optimal price. And then we're just going to fill in all the information that we need. The optimal quantity for the class project was 625 items. It'll be different for your project, obviously. The demand function is this quadratic. It starts here, has a q squared term, has a q term, has a constant term. So it's just up to the 586. Then we subtract off the optimal price, which we found to be $402.19. So if I take this integral, I'm going to get the consumer surplus. And so to compute that integral, you might want to combine like terms. So here, if I combine 586 minus 402.19, I end up with 183.81. And then I have the integral of a polynomial. So I'm not showing the work, but we're going to take the antiderivative of each of these three terms and then use the fundamental theorem of calculus to compute the actual numerical value. And so that is 71,274. So what we're saying here is that the integral of d minus p is equal to this number. This is directly out of Desmos. I'll show you that in a moment. Here's the picture of that. And so this region here, the consumer surplus, is a total of $71,274. In Desmos, it's going to look a little bit like this. So I've kind of built it for us already. And what I want you to notice is that once you have your functions entered into the formula bar here, like here's the demand function I've put in, And here is the flat line for the price. I can't put a plus here, so I'll just call it P of X, but it's just a flat line at 402.19, which is this blue horizontal line. Okay, and then what I can do is I can literally enter an expression for the integral, and Desmos will actually calculate that area for me. The way I do this, I would type in int, it inserts the integral symbol for me. Lower limit of integration is 0. The upper limit of integration is 625. And then I'm going to, because I've already defined the demand function and the flat price function in terms of function notation, I can just type in the function d of x. It's going to know to go grab this up here. Subtract off the flat line function, p of x, and then make sure I put in dx so it does the calculation for me. And there we have it. So that's how you can use Desmos to compute this and check your answer. But be aware, in the updates and in the project, you're going to want to be able to show how you get from here to here using antiderivatives and using the fundamental theorem of calculus. And so when I ask you to write that up in the updates, make sure you show all those steps. It's okay to check your work using Desmos, like I just showed, but it is important that you know how to do that by hand, both for the updates and for potential exam questions.